Imagine standing in the middle of a calm, sunny field, recalling a news story you once heard about a family whose home vanished in minutes, all from a twisting funnel of wind, and wondering if the same could ever happen here, feeling the warmth of the sun on your skin. When suddenly the sky darkens, the wind picks up, and a distant rumble echoes through the air. Birds scatter, and the air grows heavy with an eerie silence. In just minutes, a twisting, roaring funnel cloud touches the ground, leaving a trail of destruction in its path. How does something so powerful and terrifying form out of thin air? Tornadoes are born from a rare and unique combination of weather conditions. It all begins with a thunderstorm, but not just any thunderstorm, a special kind called a supercell. Supercells are the strongest and most organized types of storms, and they form when warm, moist air from the Gulf of Mexico rises and meets cool, dry air from the Rocky Mountains or Canada. This clash of temperatures creates instability in the atmosphere, like shaking a soda can before opening it. The pressure builds, waiting for a trigger. As the warm air rises quickly, the cooler air sinks, and winds at different altitudes blow at different speeds and directions. This causes something called wind shear, a tilting and rotating of air currents. Picture a rolling tube of air high above the ground, invisible to the eye, spinning horizontally. The powerful updrafts from the storm tilt this rotating air upright, turning it into a vertical column of spinning wind. Once this rotation is set in motion, the spinning air tightens and speeds up, much like an ice skater pulling their arms close to spin faster. If the rotation reaches the bottom of the storm cloud and extends all the way down to the ground, a tornado is born. The narrow funnel cloud you see is simply the condensed water droplets formed by the cooling air, swirling around a core of violently rotating wind. Measuring tornadoes is crucial for understanding their potential impact. Scientists rely on various tools and techniques to gauge the intensity and path of these powerful storms. Doppler radar, storm chasers, and satellite imagery all play a role in collecting valuable data. This information helps meteorologists predict tornado behavior and issue timely warnings, ultimately saving lives. Tornadoes vary in size and strength. Some may last only a few minutes and cause minor damage, while others can stretch over a mile wide, tearing through everything in their path for dozens of miles. The enhanced Fujita EF scale measures a tornado's strength based on the damage it causes, ranging from EF0 with light damage to EF5, where winds can exceed 200 miles per hour, flattening entire neighborhoods. What makes tornadoes even more unpredictable is how quickly they can form and disappear. Sometimes, they touch down and lift back up within seconds, while others stay on the ground for much longer. The average tornado lasts about 10 minutes, but those brief moments can change lives forever. Scientists use Doppler radar weather balloons, computer models, and even the daring work of storm chasers to study tornado formation. Despite all this technology and effort, predicting the exact time and place a tornado will strike remains incredibly difficult. What meteorologists can do, however, is identify the conditions that make tornadoes likely and issue warnings so people can take cover. Understanding tornado formation helps us better prepare for these natural disasters. It reminds us that while nature can be fierce and unpredictable, human knowledge and technology are always improving, giving us a fighting chance against the storm. As the famous scientist Louis Pasteur once said, "Chance favors the prepared mind." So the next time the sky darkens and the wind picks up, you'll know just a little more about the invisible forces at work, spinning, twisting, and waiting for the perfect storm to unleash a tornado's fury.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.